See, first we'll see mathematical formulation of the problem. So let x be the number of table and y be the number of chairs. It's a day-to-day life problem. Let's see. Here, let x be what? Number of tables, and y be number of shares that the dealer buy. The dealer is there. He used to buy chairs and tables, and we are assigning x be the number of tables and y be the number of chairs. The dealer buys, right? Obviously, x and y must be what? They are non-negative. They must be positive. That is nothing but x is greater than or equals to 0, y is greater than or equals to 0. What we can call it is non-negative constraint, right? They are always positive value. Usually area you can measure, length also you can measure in positive quantity. Always we use a mod there, right? If a negative value also there, then we can convert it into positive. Similarly here also we can take the positive constraint, that is non-negative constraint we can say. The dealer is constrained. Next is the dealer is constrained by the maximum amount. Here see, amount and cost, profit, these are includes here. Maximum amount he can invest. Here it is 50,000, and by maximum number of item he can store, it is 60. Stated mathematically it is, right? So how can we state it as? Investment constraint, let's see, 2500x plus 500y, which is less than or equals to 50,000. Investment constraint it is, right? Next we reduce it, it becomes what? By reducing this, 5x plus y less than or equals to 100, and x plus y, which is less than or equals to 60. Storage constraint. It's a storage constraint, right? So the dealer want to invest in such a way to maximize his profit. Say Z, what we can take? Already the values has been given. Constraint here, these two are the constraint, right? It is, take it as equation 1, it is equation 2. Next, objective function. Here the objective function is Z equals to 250x plus 75y is called objective function, right? So mathematically we can write it as maximize z equals to 250x plus 75y subject to constraint 5x plus y less than or equals to 100 and one more x plus y less than or equals to 60, and the non-negative constraint x comma y is greater than or equals to 0, right? So let's see how we can solve it graphically. Z equals to 250x plus 75y subject to constraint. So let's see the graphical solution here. It's a x-axis, it's a y-axis. Variables are two here, right? We are taking 2D. So first of all, we will consider the values here. Solution 5x plus y less than or equals to 100 equation 1, x plus y less than or equals to 60 equation 2, right? Objective function is what here? Maximize z equals to 250x plus 75y is the right. First we have to convert the linear inequalities into inequalities. Convert inequalities to equality. 5x plus y equals to 100 and x plus y equals to 60. So put when x equals to 0, what we get? Y value. X equals to 0, y value is 100. When y equals to 0, x value is 20. Similarly, when x equals to 0 in this equation, y is 60. When y equals to 0, x is 60, right? By using this, we can plot our graph. So let's see. So origin. Usually graphs are plotted in graph sheets only here. We get accurate values. Simply I'm showing here. So let's see. We can take it's at 10 centimeter, 20, 30, 40, 50, 60, 70, right? So here also 10, 20, 30, 40, 50, 60, right? Up to 100 is there. Y value is maximum 100. So you can extend it. So we can extend it up to 70, 80, 90. It is 100, right? So let's see. Now connect these two. X value is 60 and y value is 60. X value is 20 and y value is 100 here, right? So just connect this 60, this point to this point, these two. So we have connected this. Similarly, X is 20 and Y is 100 here, right? So connect this also. So you have plotted connected X and Y values here. So it is nothing but this line is, it is X plus Y equals to 60, and this one is 5x plus Y equals to 100, right? So let us take the points here. It is point A, it is nothing but X is 20 comma 0, and it is also point, it is A. This point of intersection what we have taken, it is B. This point is taken as C. We will take this point as D, and this point as E. E is also 60 comma 0, whereas point C is 0 comma 60, and it is point D is 0 comma 100. The point of intersection we have to find here. Point of intersection is 10 comma 50. It is 10 exactly on x-axis. On y-axis actually it is 50. We have not taken on a graph sheet, so the range is up down little bit, so it is exactly 50. It is 10, so B is 10 comma 50. If you plot on a graph, you will get exactly 10 comma 50 it is, right? So let's see now the reason, feasible reason. We have to find the feasible solution now. Already we have plotted a graph by converting linear inequalities into equality. So here we get all the points. It is the origin 0 comma 0, right? So now check whether which reason is here feasible reason, and we can say feasible solution. So already we have how many reasons here? So it is one reason, it is one reason, it is one reason, and it is one reason. 4 reasons already we have. So whether we have to check now which reason is a feasible reason here, or we can say the solution reason, we can say feasible. 4 reasons are there here. 1, 2 is 1, 2, 3, and this one is 4. Fourth one is what? It is unbounded, whereas these 3 are bounded, right? Already we have discussed about bounded and unbounded reason also. So these 3 are bounded because they are closed circles, whereas fourth one is unbounded. So here solution does not exist, right? In unbounded we can say if it is unbounded, then the maximum or minimum value of objective function may not exist here in unbounded. So usually solution exists in bounded reason only. So let's check which reason is bounded here, which is checked by using a simple method. Just substitute, see, 5x plus y less than or equals to 100 is there. When we substitute the origin 0 comma 0, x is 0, y is 0, what it get? 0 is less than 100. When it is true, then we go for origin reason, this reason, below reason, right? This 5x plus y is nothing but this line. 5x plus y is this line, right? Only two reason. If it is true, then we go for below reason, right? If it is false, then we go for this 5 plus y equals to 100, right? If it is true, then we are going this below reason. It is near to what? Origin, right? So it is true. So then we go for this reason, right? So next, x plus y less than or equals to 60. Again substitute here origin 0 comma 0. It becomes 0 is less than or equals to 60. So this line, it is also taking origin side values, means it is also true, right? True for these two values. This reason includes this much whole reason, right? Whereas 5x plus y includes this much reason only. So let's see. See, if this line is true here, we are saying this line is true, then we go for these two reasons. These two are the solution reasons. Again, this line is also true, we are saying this line means again these two lines. So in this we can take a common reason. These two are the solution reasons. Here also these two are the solution reasons. So now which one is a common reason here? In this, which one is common reason here? These two are the solution reasons for this line, whereas these two are the solution lines for this reason. So the common reason is nothing but what here? This reason is common reason here. This reason is what? It's a common reason. So we can say it is our feasible reason, or you can say solution reason. We neglect this one and we neglect this one because these two are not common reasons. But this reason is include this line also and this line also. They are common. It is true for this line. It is also true for this line, right? So with this, we have to got the feasible reason, right? So next, we'll solve the maximum or minimum values by taking the corner point of the feasible reason, right? So let's see vertex of feasible reason, vertex of feasible reason, and corresponding value of z, right? So let's see corner points of this table. We have to take the corner point of the feasible reason. The corner point of feasible reason is what here? It's a 0, 0 is corner point of feasible reason, and the value a 20, 0, and the point of intersection b 10, 0, and this point c. These 4 points we can consider in the vertex of feasible reason, right? So next corresponding value in that we have to substitute, and we will get the maximum or minimum value of the objective function. So let's see 0, 0, c 0, 60, b 10, 50, a 20, 0, right? So here let's see, when we substitute the objective function z equals to what it is exactly, the value of z is 250x. Objective function, that is nothing but, what is objective function here? Let's see once. The objective function is 250x plus 75y. 250x plus 75y, right? Just substitute the value 0, 0 in this equation. It is 0. When you substitute the value 0, then if you substitute x equals to 0 and y equals to 60, what you get here? 4500. And when you substitute x equals to 10, 250 into 10 and 75 into 50, you will get 6250. And finally when you substitute a equals to x equals to 20 and y equals to 0, here you will get 5000. So let's see here, the maximum value is what here? It is 6250. At the point of intersection, we will get the profit. The profit is nothing but we observe the maximum profit a dealer result to from the investment strategy of buying 10 tables and 50 chairs. If we buy, then you will get a maximum amount after sale, that is 6250. Here X stands for what? X is for chair. X is for table, right? Y is for chair. It is 10 tables and 50 chairs. If you buy, then you will be in the maximum profit, right? Got it? How to solve a graphical solution? So with this, how to solve a graphical solution we have seen, and some definitions also we have discussed in this lecture. So in the next lecture we will see exercise 12.1, right? And some different types of linear programming problems are there. In that, what we come across there, and later on after graphical solution we come across different types of linear programming problem. That is nothing but first one is manufacturing problem. Second one is diet problem. Third one is transportation problem, right? So we'll see manufacturing problem, diet problem, as well as transformation problem. It is in exercise 12.2, right? So in the next class we'll come across the exercise 12.1 and as well as 12.2. In 12.2 the question is giving in theoretical form, so we can convert it into the mathematical form. Later on we will solve as usually as we solved in this problem. So with this we will conclude our today's lecture. The next lecture we'll see the exercise problem.